Welcome. Today we'll analyze a position function and explore both average and instantaneous velocity. Let's look at our problem. We need to plot the position function x equals 34 plus 10 t minus 2t cubed from t equals 0 to t equals 3 seconds. Let's break this down into steps. First, let's plot the position function. Here's our coordinate system, with time on the horizontal axis and position on the vertical axis. Now, let's plot our position function. At t equals 0, the position is 34 meters. As time increases, we can see the position initially increases due to the positive 10t term, but then starts decreasing due to the negative 2t cubed term. Next, let's find the average velocity between t equals 0 and t equals 3 seconds. Remember, average velocity is the change in position divided by the change in time. Let's plug in our values. At t equals 3 seconds, x equals 7 meters, and at t equals 0 seconds, x equals 34 meters. So that's 7 minus 34, divided by 3 minus 0, which equals negative 9 meters per second. Now for the third part, finding when the instantaneous velocity is 0. The instantaneous velocity is the derivative of position with respect to time. To find when the velocity is 0, we set this equation equal to 0 and solve. 10 minus 6t squared equals 0. Adding 6t squared to both sides, 6t squared equals 10. Dividing both sides by 6 and taking the square root, t equals plus or minus the square root of 10 over 6, which is approximately plus or minus 1.29 seconds. Since we're only considering the time interval from 0 to 3 seconds, we only use the positive solution. This means the instantaneous velocity is 0 at approximately 1.29 seconds, which corresponds to this maximum point on our position graph. This makes sense because at the maximum point, the object momentarily stops moving upward before beginning to move downward, giving us an instantaneous velocity of 0 at that point.